All right, we are going to be looking at 2.6, and this will be finding the domain and range of a function, determining functions, and solving expressions. So in terms of functions, the domain and range are the x and y coordinate values in a function. The domain refers to the values moving left and right. The range refers to the values moving up and down. So there are many types of functions. Some types that you may be familiar with include linear, quadratic, exponential, logarithmic, absolute value, and rational. Each of these functions has their own distinct properties and features on a graph, which you'll learn about later. The most important points about functions to remember are that they are defined by sets of their x values, inputs, or domain. So when we're saying the input, the x value, or the domain, we're talking about one set of numbers. And then outputs, y values, f of x, and range, we're talking about a second set of numbers. So inputs and outputs. That's really x values and y values. We can also refer to y as a function of x. And then the domain and the range. So these are the inputs, these are the outputs. In talking about domain and range, I'm just going to do these ones on the left here. Our domain are just all of our x values. So all we have to do is list our x values. I'm going to list them in order. So I have -2, comma, +2, 4, 6, and 8. And then our y values. And we are listing those as -5, 3, 4, and 5. So I had -5, 3, 4, and 5. If you notice, I didn't list the second 4 because I don't need to. As long as I list one of them, I'm good. Let's take a look at C. Same idea. I'm not going to color coordinate these, so I have my x values of 1, 2, -2, 3, and -3. And then if you wanted to, you could go back and list them in order. So like -3, -2, 1, 2, and 3. And then our y values, our range, we have 1, 4, 4 again, so I'm not going to list that twice, and 9, and then 9 again, so I'm not going to list that twice. So our domain and our range. I'm actually going to skip the last one too. Okay, so mapping is a more visual way to list the domain and range. And this is where the numbers from the domain are listed in a column, and so are the range, and then we just draw arrows to each. Mapping helps because in order for a function to actually be a function, each x value can only have one corresponding y value. So each input only leads to one output. And we'll see kind of what happens here. So my input of 2, 3, so here's 2 to 3. 4 goes to -5. 8 goes to 5. 6 goes to 4. -2 goes to +4. If you notice, my -2 and my +6 both go to 4. But that's okay. This is a function. So this is a function because each x value only goes to one y value. In example C, I have 1 to 1, 2 to 4, negative 2 to 4, 3 to 9, and negative 3 to 9. This is a function. Because each x value, each domain value, only has one corresponding range value. The ranges doesn't really matter if there's multiples of those. It's kind of like a soda machine. If your button, if you go to hit Coke on a soda machine and you get a Sprite out, that is not a function. You did not get out what you ordered. If sometimes you get Coke and sometimes you get Sprite. If you have a Coke button and you have another Coke button and you both get Coke out, that's okay. So kind of a silly example, but we'll take a look here. Each 1 to 1, 2 to 1, 3 to 1, 4 to 1, 5 to 1. Yes, this is a function because each input only has one corresponding output. In F, 1 goes to 1, 2 to 2, 3 to 3, 3 to 4, 4 to 4, 5 to 5. This is not a function. Because in this one, we have an x value that has two y values attached to it. And that is not a function. That ruins it. We can also test by we can also check by doing the vertical line test, and we talked about this in class. But if we were to draw a vertical line through our graph, this is saying if my x value is 0, it only has one corresponding y value on the graph, like that's being graphed. If my x is at positive 1, I only have one corresponding y value here. So this is a function. In my next one, if you notice, my x value ends up having 2. It hits here and here. This is not a function. So this is no, this one was yes. We'll keep cruising. If I check here, my x value is only hitting once at any given time. And so because it only hits once, this is a function. So yes, this is a function. Okay, talking about function tables. Inputs and outputs, inputs and corresponding outputs can be solved for using a function table. So a lot of times we have inputs and outputs when we have, when we're working with equations. So when we're working with equations, one of the things that we like to use if we have not been given numbers to work with is what we call our 5 favorite numbers, and that's going to be -2, -1, 0, 1, and 2. So on a table here, essentially what we're saying is if we were to make x a value here, and then we worked all of that out, what would we get for y? So if we made x a -2 or a -1 or a 0 or a 1 or a 2, and we plugged it into the function 2x minus 3, so we're going to replace x with each one of these. What do we get for y? So let's go through and replace. So I'm going to replace this with a -2, a -1, 0, 1, and 2. And I'm going to solve each one out using some mental math. So I'm saying 2 times -2, which is -4, minus 3 gives us -7. 2 times, if you needed to write this out off to the side, you would do that. 2 times -1 times -3 is 2 times -1 is -2 minus 3 gives us negative 5. Okay, 2 times 0 is 0, minus 3. So when we input a 0, we get out a negative 3. Um, 2 times 1 is 2, minus 3, which would give us a negative 1. And 2 times 2 is 4 minus 3, which would give us a positive 1. And we could write these as ordered pairs. So when we plugged in a negative 2 for x, we got out a negative 7 for y. When we plugged in a negative 1 for x, we got out a negative 5 for y. When we plugged in 0 for x, we got out a negative 3 for y. So on and so forth. That same idea works here in B. I'm not going to use all 5 of those though. I'm just going to use negative 1, 0, and 1. So if x is negative 1 and we plug it into this equation, what do we get out? If our input is one thing, what's our output? So if my input's negative 1, I'm going to take the absolute value of negative 1, which is positive 1, multiply that with 2, so 1 times 2 is 2, plus 4 gives me 6. If the mental math thing, if you're not comfortable with the mental math, write it out off to the side. Say 2 times the absolute value of negative 1 plus 4. So the absolute value of negative 1 is positive 1. 2 times 1 is 2. 2 plus 4 is 6. If I plug in a 0, the absolute value of 0 is 0, times 2 is 0, plus 4 is 4. And then if I plug in a positive 1, the absolute value of positive 1 is 1, times 2 is 2, plus 4 is 6. So when I plugged in a negative 1, I got out a 6. When I plugged in a 0, I got out a 4. And when I plugged out in a 1, I got out a 6. And then this is our domain, all of our x values. Our range are all of our y values. All right, the last part, function notation. Essentially, we're going to replace y with f of x. We say it f of x, f at x, or the value of the function at x. This one's particularly helpful when we're working with graphs. Values are then given for x, and we plug them in and solve. So essentially, all we're doing is this is telling us, hey, replace x with a negative 4. Replace x with a negative 5 and solve. What happens? So when we replace with a negative 4, I'm going to say f of negative 4 equals 2 times negative 4 plus 3. So f of negative 4 equals negative 8 plus 3. So f of negative 4 equals negative 5. So when I plug in a negative 4, I get out a negative 5. Let's do the same thing for f of 5. If I plug in a 5 for x, so I'm going to say 2 times 5 minus 3, then we work that out. 2 times 5 is 10 minus 3. So f of 5 is 7. All right. And then finally, I'm going to be doing the same thing but with an absolute value. So if f of 6 equals 2 times 6, 2 times the absolute value of 6 plus 4, the absolute value of 6 is 6. Two times 6 is 12 plus 4, which is going to give us 16. So f of 6 is 16. I can do that same thing with negative 3. Two times the massive absolute value of negative 3 plus 4. The absolute value of negative 3 is positive 3. So 2 times 3 plus 4 is 6 plus 4. 6 plus 4 is 10. So when I plugged in a negative 3, I got out a 10. Okay, and I'm going to skip this one. So hopefully that makes sense. We'll be practicing it in class. If you have questions, be sure to ask then.